Okay, welcome ladies and gentlemen. Let's do another example. Let's do the following. So let f of x, let f be defined on the real numbers to the real numbers, and let's define f of x as follows. So f of x is 2x cosine x squared minus 1 plus 3, and this is for all x in the real numbers. Prove using the definition that the limit as x tends to 0 of f of x is equal to 3. Okay, let's do this. So first thing we do is let's write out exactly what this statement means. This means something very specific. It means the following. It means for every epsilon greater than 0, there exists a delta greater than 0, so that if 0 is less than absolute value of x minus 0 is less than delta, then the function value, the distance of the function value to 3 is less than epsilon. Less than epsilon. So this is what we need to prove. This is the statement that we need to prove. Okay, let's start with our proof outline as before. Proof. And let's write here outline. Okay, what do we need to do? We look at the statement that we need to prove. We want to prove something for every epsilon. So first thing we do is we say fix any epsilon greater than 0. Then next thing that we need to do, we need to show that there exists a delta. So we must define it. So define delta to be something, must be greater than 0. And what are we allowed to use? We are allowed to use epsilon. Allowed to use epsilon. We are only allowed to use our previously defined symbols. Okay, so that takes care of that part. Now we want to show that if x minus 0 is less than delta, then absolute value of f of x minus 3 is less than epsilon. So we assume we want to prove this implication. So we assume the hypothesis, assume that 0 is less than x minus 0. So that I'm going to leave out. Assume that, and now here we need to do a bit of work, and finally we want to conclude. Let's write it properly. We conclude, comma, under the assumption that 0 is less than x less than delta, that f of x minus 3 is less than epsilon. That is what we want to conclude in our proof. So we assume the hypothesis of our implication and we want to conclude the conclusion. Okay, so here is our proof outline. Notice here that this did not take any thought. This is purely mechanical. You can train your hand to do this by itself. You do not need to be able to think to do this. Okay, let me duplicate this page and let's write out our proof for realsies. Okay. So let's start here. We are interested in this expression, f of x minus 3. let us substitute f in. So what is f? F is 2x cosine x squared minus 1 plus 3. So 2x cosine x squared plus x squared minus 1 plus 3 minus 3. Okay, the 3's cancel out. We are left with 2x cosine x squared minus 1. Okay, if you know your absolute value, you will be able to see that this is the same as this. Okay, but this thing, if you think about what the graph of the cosine function looks like, he looks something like that. He never takes values greater than plus 1 or less than minus 1. So if you take the absolute value, so the absolute value is going to flip it like so, and it doesn't matter what input you put in here, this thing is always less than 1. So this entire thing is less than or equal to x, is less than or equal to 2x. This is because, so since cosine x squared plus 1 is less than or equal to 1. Okay, we're running out of space here, but luckily I can just copy and paste this part. So cut, paste. Cutting and pasting is your friend. So let me resize this a little bit over here. Ding. Okay. Now, let's see where we are. Remember where we are heading with this expression. What do we want in the end? In the end, we want this thing to be less than epsilon. So far, we have it less than or equal to 2 times absolute value of x. But notice here, we have made this assumption that the absolute value of x is less than delta. So this thing is less than 2 times delta. But now, again, we have full control of the delta. Now, by choosing our delta appropriately, we can get this expression to be less than epsilon. And we see here, if we choose our delta to be a half epsilon, what happens? So this then becomes 2 times a half epsilon. The 2's cancel, which is equal to epsilon. So we have this thing is equal to that thing, is equal to that thing, is equal to that thing, is less than or equal to that thing, is strictly less than or equal to that thing. So if we forget about everything that happens in the middle here, we have this thing is less than that thing, strictly less than. And here we have already written down our conclusion. So we conclude under the assumption that 0 is less than x is less than delta, that f of x minus 3 is less than epsilon. And here we have our proof. Okay, so that is it for this example. I will see you in the next one.